driving mechanism and what is the driving entity? Because I assume when you say tumor, you deal with a lump and you consider that the whole lump is one entity and it behaves in the same manner to all its extensions. So we're going to see here that many of those, what you know, is actually assumptions and they are not true. Actually, they are by far not true. And what are the recent achievements in order to deal with this disease once and for all? And whether this is achievable today or it's going to become in the near future. So we are going to see the cancer physiology. We are going to give definitions because we say cancer-free. Remission and cancer-free are two different things. When we say that I cannot detect by an MRI, a CT, an ultrasound, a tumor, doesn't mean that the tumor cells are not there. We're going to be familiar with terms so that they are critical, like the limit of detection. Every test that you're doing on your life, they have a limit of detection, which means that they can see from a point and after, not below that point. Which means that below that point when the disease is there, your measurement is not able to detect it. And this is critical when you deal with cancer. When we say diagnosis, what do we actually mean with that? And how accurate we are in our clinical practice? How we do the treatment decisions? Because after all, it's not rocket science. We may hide behind difficult terminologies, but the old process and algorithms are relatively simple. And what are the statistics? And of course, we are going to be familiarized with the entity which actually is responsible for the cancer progression, the disseminated tumor cells, or otherwise circulated tumor cells, definitions around them, what kind of technical issues we deal with them, what is the utility of them, and how we are going to apply them in clinical practice, and what are the future perspectives. Let's start with the basics. How we define cancer? Because a lump doesn't mean it's cancer. It may be a benign. When a lump is able to constantly grow, it doesn't die. When it invades to the healthy tissue which is around this lump, and whether this tumor attracts the formation of new vessels so that the blood supply comes towards the tumor, so that the tumor will be fed by nutrients and oxygen, then this tumor is defined as malignant. So, immortalized cells able to metastasize are the critical definitions there. In the laboratory we have one more term, but this is by far not relevant with you. So I'm not going to familiarize you with that. But in practicality, we need to take a specimen from this tumor, and when we put it on an animal model, which is immunocompromised, this animal, the tumor needs to regrow in the animal exactly in the same manner as in human. This is called orthotopic modeling. Only then we are sure that these abnormal cells are defined as malignant. But this is for the laboratory purpose. So we are going to stay on the definitions that Professor Weinberg has correctly defined. And if I ask you, what is the cause of cancer? I'm pretty much sure that 90% of you are going to tell me it's mutations that actually caused it. Am I correct? Anyone else that has a different opinion? Well, actually, this is not the cause, the mechanistical cause, but your life lifestyle, your environment, the viruses, the radiation are actually causing damages. But these damages, most of the time, we consider that exist on a DNA level. So it means mutations. Well, think again. Because we have seen malignant cells without specific mutations, that they have abnormalities on the RNA level. And the RNA is reversely transcribed to DNA and becomes part of our genomic DNA. We have, of course, the mutations. We have abnormal proteins without altering their sequence. As you can understand, the proteins are actually, imagine them as a string, big one, which actually folds. And it needs to fall in a specific way so that this protein becomes functional. If this folding is different of the normal, gives either switch off of the activity or overactivity. We have seen misfolded proteins which can actually cause malignant phenotype without the presence of mutations. And of course, recently everyone is talking about a new category of RNA called microRNA, which regulates the expression of genes. And the alteration in the pattern of microRNA can cause cancer. So as you can understand, it's not only an issue of genome, but the abnormalities exist on all levels of biomolecules. So it's not an easy case. How the disease is developed. So correctly you have said lifestyle. Actually, you described correctly the first step of the Vogelstein model of carcinogenesis, which is the initiation. Our lifestyle means that the microenvironment of normal cells, which either they may carry viruses, chemical radiations, and when we say chemicals, doesn't mean small organic molecules only. Even stress, which means multiple organic molecules which stimulates our cells continuously, like local hormones, they may lead to malignant phenotype at the end. So this is the first step of carcinogenesis, which at the end you conclude with abnormal cells. Not malignant, abnormal. If everything goes well, and let's say the cause is stopping at that point, we may have a chance that the organism will fix the mistake and eliminate these cells. If the microenvironment continues to be the same, then we have abnormalities which conclude with inabilities actually. When the cells become unable to repair the damages on the DNA or proteomic level, or they are not able to regulate the cell cycle, which means that they cannot control how fast or slow they will replicate themselves, then we have the promotion. This is the point where the cells are becoming dysplastic. Highly abnormal, but still not cancerous. When the cells become able to migrate, invade and metastasize the distant organ, only then we have the final development of malignant phenotype. How long do you believe this lasts? Just a guess. I prefer to make it more interactive because it would be much more challenging for you.
A few months.
5 to 20 years. So when you have a tumor, it's not a story that happens a few months ago. When you have a recurrence, yes. But the primary tumor, it's not a story of a few weeks or months. It's a process of years. So, as you can understand, carcinogenesis is something that it can be prevented, and I proudly said that, as the ancient Greek Hippocrates said, it's better to prevent instead of treat. We could focus our interest after treatment on prevention.